Today I'm going to be talking about the pilot flight planner for my client's flying club. To begin, we're going to go into VS Code and run the program since it's housed here. And this is the first page that pops up. As you can see, there are many places for the user to put input, and there are some drop-down menus as well. Today we're going to be talking about two users, John Doe and Bob John. They have different levels of experience and own different aircraft. So let's start with John and show you how this works. Let's start by putting in his information, along with some of the general flight and weather information. The cloud coverage is what's basically available at the time, and the weight limit would be the weight of him along with all his baggage, the aircraft, etc. So talking about some test cases and success criteria, let's go to test case number 2, where the client requested for some easily choosable subsystems that create different outputs, such as the pilot level and the aircraft type. So let's put his pilot level, which is IFR, and his aircraft, and proceed from there. Also, test case number 6 talks about how specific drop-down menus will trigger specific weight and limit values and variables, which we will see in the upcoming GUI interface, which shows the kneeboard diagram. Talking about success criterias and the test case number 7, it's talking about how all buttons are functional, so let's check that right now. It pulls up the kneeboard diagram, which shows us a reprint of the pilot name, airport name, and frequencies, but there are changes to the temperatures, cloud coverage, and the go-no-go decision. Talking about test case number 9, we can see that the values are correct according with FAA guidelines, which are the Federal Aviation Administration, and their legal values that they require. So these values right here. Let's go check on their pamphlets, FAA pamphlets, that talk about the weather minimums, and we can see that they all are in accordance. Moving on to test case number 3, which talks about a go and no-go decision being made. Based on if the temperature dew point spread is safe, if the weight limit is safe, and if the cloud coverage limit is safe, a decision will be made whether it's advisable and safe to go out and fly on a particular day. Going on to test case number 10 as well. The store data button will store data in an easily trackable file. So let's try that out right now. Yep, this file was just created, and it is stored really easily to track because it is stored by the year, month, day, and even holds the time of when it was created for easy accessibility. Let's look at it right now. Here it is, and it produces a very systematic and easy to understand kneeboard diagram for future use. For example, if when the pilot wants to go up in the air, they can take this with them to see their conditions, to remember their tower and ground information along with airport information. So that was John Doe. Now let's move on to Bob. Let's run the program one more time. And input his information. He is a VFR pilot that flies a Cirrus and just goes to the same airport as the other pilot. The cloud coverage is the same at 2,000 feet, but the weight limit is different, which is at 4,000 pounds. Let's see how this reacts. Now, talking about test cases, let's go to test case number 4, which talks about how error checks are conducted when fields are invalid. So let's pretend John Doe was tired that day or something, and he puts his name, Bob was tired that day and puts his name here and tries to create a flight plan. Oh, there's a pop-up that talks about putting a valid numerical value. So let's fix that, and then dew point as well. Moving on to the kneeboard diagram, which pops up right here. So this information is printed once again, and we have our new go, no-go decision. Talking about case number 5, we were able to see how the system allowed the user to re-enter select data. The old temperature, which did not have a numeric value, showed a pop-up screen and allowed the user to add a new temperature and skip the hassle of re-clicking the button and all that by directly coming to the kneeboard diagram page. So we can see how this works. Let's once again see how it stores the data right in front of our eyes, creates a new file based on the new time that we created the file on, and represents the new data, which will pop up any minute now, right there. So let's talk about some of the success criteria. All the success criteria were met successfully for my user, and throughout the process of building the code and the prototypes, I was in constant communications with them to evolve the design and better fit their needs. Talking about extendability to the future, I believe that naming the files in a more easy to retrieve way might allow better usability, since there are two files from different users created in the same day. By allowing it to be more customizable, it might prevent mix-ups and help the future of the flight club. Additionally, turning this program into an app might be very helpful because it allows pilots to see their flight information on the go. Additionally, I believe that the basic features that are provided in this can be extended to include more things about the visibility, more about the weight limit components, the fuel capacity, etc. So for the extendability, I believe that more flight calculations can be made to allow a better user experience and more capabilities. Thank you very much.